Hello everyone, welcome to this video. In this video we are going to study about factory pattern. It is one of the most important creational design patterns. Now let's first understand what is a factory pattern. The factory pattern is one of the most commonly used design patterns in object-oriented programming. It falls under the category of creational patterns which deal with object creation mechanisms, trying to create objects in a manner suitable to the situation. The factory pattern provides a way to create objects without exposing the instantiation logic to the client and refers to the newly created object through the common interface. Now, what is it all about? Let's see this with the help of a working code. Now, let's try to demonstrate the usage of factory pattern. Let's create a simple factory that creates different types of vehicles based on input. We will have a vehicle interface and different implementations like car and bike. The vehicle factory will be responsible for creating the instances of these classes. So let's first start by creating a vehicle interface. Let's call this vehicle. The simple interface just containing one method, void drive, and we will be creating two implementations of this interface. One is car. We will say implements vehicle, and let's override the method drive. Just say drive car. Okay. Similarly, let's make one more implementation of vehicle, bike. We will implement vehicle. Let's implement the method drive. So we'll say ride bike. Okay. Now we will be creating a factory. Let's call it vehicle factory, and we'll create a helper method, public vehicle get vehicle, and in parameters I'm asking the user to specify the type of vehicle type. So let's handle the base case first. If vehicle type is null, then just return null. Okay. Now, if vehicle type equals car, then I will create an object of car and return it. Same thing I want to do for bike also. I will rename this as bike and give the bike object. Return null. If the user specifies any other thing apart from car or bike, I will say take null. And right now I am only supporting car and bike type. Let's try to make the client code. Client code means the code which calls the factory which needs the car or bike object. Let's call it factory demo. Let's create the main method here. So we will create an object for vehicle factory. Vehicle factory is new vehicle factory. Vehicle 1. Vehicle 1 means I will use vehicle factory and say get me a vehicle of type car. And now I can invoke vehicle1.drive. I can copy this code and say, give me an object of type bike also. So I can just use vehicle2.drive. Nothing fancy that we have done here. There's absolutely nothing fancy that we are doing. We are just invoking getVehicle, and essentially what it returns is, it returns an object of type car. It returns an object of type bike. Now the question comes, we also would have done the same thing. Why are we going out of our way to create a factory for us? We'll answer these questions now. So first, let's see what we have done. We made an interface called vehicle. This interface defines the common behavior for all vehicle types. Then we implemented the concrete classes. Car and bike are concrete implementations of vehicle, providing specific behavior for each type. Then we built factory. This is the factory. We built vehicle factory. This class contains the factory method getVehicle, which takes a string parameter to decide which type of vehicle object to create. This method returns an object of type vehicle. Now, what we did in client code? Client code is a factory demo. In factory demo, the vehicle factory is used to create instances of car and bike without the client needing to know about the instantiation logic of these classes. The client may simply call a factory method and use the returned object. Right now, this client code does not know how this object of car is getting constructed. There may be a more complex logic to construct the car, but it is hidden from the client. The client doesn't need to go into those details. Plus, our code also is clean. Let's say tomorrow we need to make changes in the implementation of the construction logic of car object. We need not visit the client usage of the code. We will just go to the factory and make changes here, how the car object gets constructed. And this is the benefit of factory pattern. First benefit is abstraction. The client code only deals with the vehicle interface and not the concrete classes. Maintainability. This is the second advantage. If we want to add a new type of vehicle, say truck, we can do so by creating a new class truck, implementing vehicle, and updating the vehicle factory without changing the client code. The third advantage is separation of concerns. The logic for creating vehicle objects is separated from the logic for using these objects, making the code more modular and easier to understand. So, these are the advantages of using factory pattern. First is decoupling. It avoids tight coupling between client code and the concrete objects. Single responsibility principle moves the complex object creation logic into one place, which was factory. Open and closed principle. We can add new products without impacting the client code. These were the advantages of using factory pattern. Now let's see the disadvantages. The disadvantage is code may become more complicated as you may need to add more subclasses. Like in this example, we made subclasses car and bike. So additional subclasses need to be generated and code may become somewhat more complex. Let's see all the places where factory pattern gets used within Java. One example is collections. In Java collections, you might have seen code like synchronized list, unmodifiable list. This uses a factory pattern. Java Collections Framework uses factory pattern to create instances of various collection classes. For example, collection class provides factory methods for creating read-only collections like this, unmodifiable set, or synchronized collections like this. So this is one example where factory pattern gets used within the collections framework. Let's take a look at another example, JDBC connectivity. You might have used this piece of code before, driver manager.get connection. This also is an example of factory pattern. The driver manager class provides a static factory to get a connection object. Let's see one more example. Logging frameworks. You might have used log4j to write up appropriate loggers in your code. Log4j and other logging frameworks often use factory pattern to create logger instances. The logger class provides a static factory method to get a logger instance. Check this code, logger manager.getLogger. So you are getting an object of type logger by using the factory method getLogger for this type class. So if you like this video, please subscribe to it so that you will get notifications about further videos in this channel. Thank you.